The second question that we have in our book is an investment pays interest at the rate of 9.8% per annum, compounded continuously. How long will it take for an investment of $15,700 to triple in value? Well, again, we need to first of all think, what is my differential equation? In this case, it's some amount that I have put into or invested. So I'm going to have some dA with respect to time is equal to, now my K value in this case, or my increase, is 0.098, which you're probably thinking, I hope, already. And it's with respect to the amount that I initially deposited. So it's with respect to my Y value, or my function. So again, we're going to have the same thing as we had before. I am going to go straight into my equation. I will then have the amount is equal to some initial value deposited and e to the 0.098, and it's with respect to t, so I'm going to put that over there. Now, that was my first part. My second part is to substitute in the values that I had. Now, I'm going to be a little bit tricky, and I'm not going to work out what triple the value is. I'm just going to say the amount that I'm wanting it to equal is 3 times 15,700, and you'll see why in a minute. My initial value that I put in was 15,700, e to the 0.098t. Now, I'm trying to solve for t. The first thing I need to do here is divide both sides by 15700. So if I divide this by 1007, then I'm just going to get that 3, which I think will also tell you it wouldn't have mattered what the value was. If you're going to be tripling it, it should work out to be the same amount of time. But that's neither here nor there. We are still looking for t again, so I don't want to have that power there. So I'm going to take the natural log of both sides, and I'm going to get natural log of 3 is, 1.096 is equal to 0.098t, and I'm going to just divide both sides by 0.098. So 1.09. Keep my answer in there, sorry, and divide it by 0.98. 0.08 equals 11.21 is equal to t. So what I'm expecting there is that the time that it would take would be approximately 11 years. Okay. If the Reserve Bank held the rate of inflation at 1.8% per annum for the last 20 years, calculate the original cost of a house valued at $350,000 today. So, what information do I have? My differential equation was that my cost, dc dt, is going to equal 0.018, and it's with respect to the cost of the house initially at that point in time. Again, I'm going to apply my integral to both sides, and I'm going to end up with the cost is equal to some initial cost e to the 0.018 and with the time. So I've got that cost is what I'm actually calculate the original cost of the house if it's valued at $350,000 today. So that is my cost that I'm looking for now. My initial cost is what I'm actually trying to calculate, and my time that I've been given is 20 years. So I will need to work that out. As you can see in this case, I'm not having to find the natural log of anything. So that kind of goes with the first video that I made, if you did watch that. So 350,000 divided by, remember E is an actual value, so if you've got what the power is, you can just substitute that right in there. So you're dividing by E to the power of 0.018 times 20. Just make sure when you're doing that you put it in your brackets so that it doesn't times your exponent by, doesn't times that by 20. It needs to be e to the power of everything there. So you need to make sure you pretty much put brackets in there and it times in your calculator. So that here seems to me that it's going to be 244. It's house prices, so we're probably going to go, it's 186 and 71 cents is equal to CO. So we could probably say that's approximately equal to 244,000 was the original cost. If only that worked. So anyway, so I hope that made sense there. I'll do one more. A bank is offering to double your money in 10 years. Find the effective continuously compounding interest rate given that dP/dt is equal to IPT. So they've given me the differential equation, which is really awesome of them. Thank you very much. So we know that my initial amount there is equal to some initial, so my amount that I'm looking for is equal to the initial amount times by e to the, now we normally have our value there, so it's going to be I, and that is going to be multiplied by t. Okay, so that is what my integral would look like. Now time, I'm told, is 10 years. So that's pretty awesome. But say it's going to double my money. That would mean P divided by my initial amount that I put in there would be 2. In other words, 2 is equal to E to the I times 10. Or 10I would probably be a better way to write that. So now again I need to take the natural log of both sides to get rid of this. So natural log of 2 is equal to the natural log of e to the 10I. I standing for interest, not complex numbers. Natural log of 2 equals 0.69 is equal to 10I. So I need to divide both of those by 10. So that will give me 0.069 equals I. So my interest rate, remember it's as a percentage, 6.9%. I will put up some more later, but I think too many in one shot would just be too much to watch. Hope that was helpful.